My great-great-grandma, like, came from Ireland when she was, like, 16 or something.
I'm Irish.
So, 4-8. General
Joyzy.
applications
Gab's here.
of Trig.
What? T-shirt time.
Gab's here.
I'm so worried about your bad accent.
Yeah, she's from Jersey.
Start off with
Degree.
solving a right triangle. If you can solve a right triangle, you could pretty much solve any word problem I can give you about
I can't, so we're in
right triangles in a word problem. I mean, it's pretty simple. So, for instance, if I tell you that this angle over here is 20 degrees, and I tell you the opposite side is 5 feet, you should be able to tell me everything else about this right triangle.
Yeah.
Every other measure, every other length. So, first off, what's the easiest thing to find first?
What's the triangle? What's it equal to?
That other angle. So
Yeah.
this angle here is equal to
70.
70. Because those two angles have to add up to 90. What is that called?
It's either supplementary or complementary.
It's either supplementary or complementary.
I get
It's
confused.
supplementary. It's supplementary.
That's 180.
Yeah.
Complementary.
I get
Oh, the triangle adds up to 180. I was just talking about these two angles.
Oh, those are complementary.
They're complementary.
The
All right.
triangle is supplementary.
Then when you're given this, you can just label the other sides like x and y. So first off, how would you find x? Well,
You do some
take the angle that they give you. Never use one you calculated later unless you have to. So take the angle they give you, take the side they give you, and you're looking for x.
You can do a ratio, right? So it's opposite over adjacent.
It's a ratio of 5 over x, but that's opposite over
Adjacent.
adjacent.
Tangent.
So this would be tangent. So you say tangent of 20 degrees is equal to 5 over x. So yeah, cotangent's great except when you get to your calculator. So it's better to just keep it in the main three functions. 5 divided by tangent of 20. Use that proportional trick where you can take the diagonals and switch them.
How do you know when you're supposed to be in degree mode or radian mode on your calculator? Well, I noticed a degree.
If I write pi over 3, you can either A, change it to degrees, or B, change your calculator to radians.
My calculator should be in degrees right now.
Because I was doing a problem last night. I think.
Unless you want to change 20 into radians, and that
That
just
just gets messy.
So x is approximately. Now these things are not going to give you exact answers. They're only going to give you approximate answers. And that makes it tricky because sometimes you have to use an approximate answer to find another answer, and it becomes more approximate, so you get rounding errors.
So it's 13.734 or whatever.
13.7 measurement?
4 something.
Feet.
Feet. Please don't say degrees.
Degrees.
Feet. All right, how would you find y? Using the same thing. The beginning angle is 20, this side is 5, and now we're trying to find y. Now, you could, if you wanted to, Pythagorean theorem, except for one problem. This thing is already rounded, approximated. So it's best to go back to this and say, oh, that's going to be sine of 20 degrees. Opposite is 5. Hypotenuse is y, and solve for y. So you get y is equal to 5 divided by sine of 20 degrees. And you get y is approximately 14.6. And this will be feet. And there you go. Now I know everything about this triangle. All 3 sides, all 3 angles. So that's basically what it means to solve the right triangle.
We're gonna do a little crown thingy.
What?
Like the.
No, you stop. This is not BK.
No, I'm pretty sure we did it in geometry. Not pretty proud. Never mind.
Same thing. Same burger.
It was. No.
Can't have it your way.
All right. Let's say there's a building.
That does have been the first lesson.
Right.
What's
There's
that?
got to be an apps.
Oh, there's. This gets
Oh
crazy.
my god.
It's a building.
Here's my little building. Here's the
Tom
door.
jump.
I will.
Oh, I thought you were doing something like serious.
I am.
This is serious.
My building.
Serious math. Serious math.
I thought the windows were part of the math.
No. And there's a flagpole right here on the building.
Just draw. Go ahead and draw the American flag.
No, I'm not very good at drawing the American flag.
Why? It's stripes and dots.
There you go.
What, you got American?
Italian flag doesn't change it. Irish, it's St. Patty's Day's coming up.
Oh,
Now, my question is this.
I was supposed to be going to Pittsburgh this weekend, so
And it's supposed to be when out.
Are you not going to?
I'm not going.
Yeah.
I went to Italy, so
I want to know the height of the flag, so how am I going to find it?
What do you mean? The flag way there?
Yeah, I want to find it from way down here.
Well,
Is
like,
there an angle
you know the
elevation?
angles and stuff.
No, I don't know angles just yet. What do I have to do first, though?
You have to
Draw a
measure the
triangle.
building.
No, you can't measure the building.
You draw a triangle.
Just draw a triangle.
The only
Yeah,
thing you
that's
get to do is walk along the base here. So you have to walk away from the base of the building and measure how far you go. So you stop here.
Why do you stop there?
Why not? Well, yeah, you have to be able to see the top of the flag and the top of the building and the top of the flag so you can measure it.
Okay.
So you back off a certain distance, let's say 100 feet.
Why not walk as little as you can?
Then you might not see the top of the flag.
I can see the top, like, just
You
fine.
fall over. Jeez. So from this position, you're going to measure this angle, let's call it alpha. And then you're also going to measure this bigger angle, let's call it beta.
Why?
Why not?
Gives you two different
Was
angles.
it?
Ah.
Does that have to do anything with depression?
Yes, these are both angles of elevation because you're looking up. Now, if you were at the flag, you would be looking down. But as you look down, this angle would be, let me think about which one it is. This would be beta, and this angle here would be alpha. You'd have to be going horizontal and then down.
Isn't alpha
What's that?
Isn't that alpha
Up here, but when you do angles of depression, it gets put up there.
Yeah.
Remember, they're equal to each other because you get those sets of parallel lines. And as you're looking up alpha, you're looking down alpha from opposite sides. So it depends on your point of view.
Very
Now, when you get a picture like this, how many right triangles are involved?
good. One.
Really?
That one's not a right triangle.
They're both
right
right
angle.
triangles.
Sorry.
This is a right angle. You get the small right triangle and the...
That is not a right.
Why not?
Oh, okay, the bigger. Okay.
My building's kind of tilted.
I see it now. No, I see it now. I thought you were talking about the little like wedge.
So you have the smaller right triangle, and this is the building, so this is where the windows are. And this is alpha, and this is 100 feet.
Okay, I see what you're talking about.
What am I interested in? Which side?
You're interested in the sign for
No, no.
the side for the building.
The height of it, the building. So I'm looking for X.
So you're doing tangent.
Alright, the other one is a little bit bigger. This has an angle of beta. The base is still 100 feet. And we're still interested in
The height.
the height, the whole height. Wow.
So that's the building.
You guys are distracted, so aren't you?
This one is the building and the flagpole. Okay.
You do.
So if you want, you can think of it as this height here, that's X. This height here is Y.
Excuse me.
So once I give you what alpha and beta are, you should be able to figure out everything. So let's say alpha is equal to,
I thought you told us we weren't getting angles for this.
what? I'm giving angles.
Yeah, you did. That's
Oh, she thinks it'd be gay day, so.
Oh. So let's say alpha is equal to 30. Now that's boring. 38 degrees.
40.
2 degrees short of 40.
what?
Now, what's beta have to equal?
45.
Can it be smaller or bigger?
38 plus whatever.
It has to be bigger. It has to be a little bit bigger. So let's say
42. 38
45.
plus whatever.
52 sounds great.
52.
52. All right. It's gonna
But
be.
it has to be less.
It might be a big flagpole that way, but we'll
Hey,
find out.
we're proud to be Americans.
We're proud to be Americans. It's a huge flagpole. Okay, so you set up the first triangle. What's the setup for the first triangle?
I'm just trying to.
I don't know. Wait.
Well, your fish.
38
Your
and
fish
then
is 38.
So you say
Tangent 38.
tangent of 38 degrees because it
X
is
over 100.
opposite over
100.
a hypotenuse. So you get, opposite over adjacent. So you get x over
100.
100. And x here is going to equal 100 tangent of 38. Do not type it into your calculator.
You made
Why
about
not?
38
I
grand.
don't.
Huh?
You
Why
made
not?
about
I made it
38.
up, yeah. You know, you stand back and you measure the angle using a protractor, or they actually have devices.
Yeah,
can't
well, we've
think
had
of
this
the
discussion.
I can't think of the name.
We've had this discussion.
Yeah. All right, you set up the same thing for beta, and you're going to get tangent of
78 point.
52.
Oh, wait,
52
no, no,
degrees.
sorry.
and it's going to be equal to
Y over 100.
y over 100. And therefore y is going to equal
100 tangent 52.
100 tangent 52 degrees. Now, the reason I don't want you to type it in a calculator is because then you'd be rounding this one and rounding this one. It's actually better just to take it and take these two things and why would I add them?
Or tell
No.
you can tell us.
No,
You
just
subtract them.
You
Just
subtract
right,
them
I'm sorry.
because what you're looking for is this distance here.
I was going to ask you that.
So this would be y
Why wouldn't
minus
you add them?
x. If you add them, they're just stacked on top of one another. So it'd be the building and the flag, and you'd have this thing that's out in space.
So
So,
I have a question.
mhm.
Why can't you just do 100 tangent 52 and then find the height?
But that would be the height of the building and the flagpole. I'm just
So
interested
looking for
in,
the space between
the flagpole.
How
How tall is the
I thought you
flagpole
were
at the
talking
top?
about just the flagpole.
yeah, just the
I thought you were
flagpole.
talking about both, okay?
Just this.
I thought you were
And I
talking
can't do trigonometry on this little triangle because there's no
about- I know.
right angles. Later we'll be able to do it,
I don't.
not now.
I
So,
don't. That's
Take these two and subtract them, but which one's bigger?
Definitely don't like
The
Y.
y. So put this one in your calculator first, put this one in your calculator second, make sure you subtract them.
And make sure to close the parentheses.
And then you find the flagpole
Thank you.
is approximately, if you're really smart, you can factor out 100, but
Yeah.
49.86.
what is it?
49.86.
Wow.
Unless I'm-
49.9
unless I'm
That is
wrong.
not a tall building.
feet.
Oh wait, that's a tall flagpole.
That's a huge flagpole. It would bend over and break.
Oh, what?
Hey, building's that tall.
Right.
Buildings. The building is.
Wait, how tall are those flagpoles in front of buildings? In front of
School?
Wouldn't that be like
They're
building-
About
huge.
30 feet.
Wouldn't that be the building
About
and the flagpole together?
Hmm. This one, the tangent
Oh,
38
well,
one,
the tangent.
that's the building.
What about the one
The
in front
tangent of 52, that's the building and the flagpole. We took these two and
Right.
subtracted them.
Yeah, these make sense.
This makes sense.
The 49 makes sense.
For about 10 seconds.
No. How dare you doubt me?
What is the worst problem I could come up with?
I'm the great eyes.
No.
We are the
No.
sadder part.
Did you say you're the great
How about
Yes.
you
I
have
can't believe you're bored.
Is this enough room for the worst problem ever?
No,
Well, this,
more than likely not.
what?
Takes up about a page.
What? Is worst problem ever better?
Drawing comes into it. Okay.
Don't you need some
Unicorn flakes.
homemade?
I don't think we can do trade.
Homemade red wine.
Mount Everest.
I don't care.
How did they find out the height of Mount Everest and know it was the tallest mountain in the world?
They climbed it.
They
Before-
closed.
But if you find it, all you can measure is this part of it.
They dug a hole all the way down.
Wow. To the center of the earth. Yeah, there you go. See, nowadays you can have a satellite and you just
And then
beam
you
something
drop
down and it
the ball.
measures.
Did you know that if we like dug a hole through the center of the earth to anywhere in the world, it would take only 40 minutes to get to the other side?
Yep,
Oh yeah,
anywhere
because
you
it's
went.
only, what, 4,000 miles to radius?
Yeah, we got computers for this stuff. We don't
Yeah.
really,
Yeah,
we don't really care
Yeah.
about this.
But I
I
mean,
don't care.
you've seen those guys in the little telescopes on the side of the road with the sticks, with the black and the white, and they're doing surveying.
Yeah.
Basically what they're measuring is,
Right.
over a certain distance, how high does the road go up?
Oh, really?
So, like, the slope of the road. So, to do the mountain calculation way back before satellites and all the fun stuff that we can do nowadays,
Why
they
would
used
you
to
wanna
have
do
to,
it this way?
they would have to start at the ocean,
Start at the ocean.
water, sea level, and measure what I'm going to do up here to a hill in the distance. They would go to that hill in the distance, measure to another hill in the distance, and keep doing this until they get to Mount Everest. So the technique is this. You cannot drill a hole down the center. You cannot measure it as you go up the slope because it's, bumpy and all that fun stuff. So you find a flat place where you can actually see the very top of the mountain, some distance away from the mountain. Now here's your problem. Here's the center of the mountain that you wanted to drill into. Can't do it, but it's still there. And this distance that you're walking away from the center,
You don't know part of that.
we don't know.
But
So
you
the
know.
best you can do is say, oh, it's X. But what you can do is pick a point where you can actually see the top of the mountain, back off a certain distance, look back at the mountain again. So you're going to get 2 angles out of this. The difference between what we just did with the flagpole and this one is we're starting with an unknown distance and then we're doing 2 measurements, but not from the same place, but from 2 different...
I thought I turned it off.
You're such a
God.
Right.
It really
from a
was.
different location. So you get this idea where this angle is going to be formed here. Let's call this one alpha. And we're going to get this angle here, and let's call this one, oops, beta.
What?
Now you're gonna add
This one's going to take a little while, so yes, I will ask this on the test.
No, I said you're gonna add the distances, right?
What's that?
What is that extra point for?
You're gonna add them in the end, right?
Where?
The theta and the beta. I mean, the alpha and the beta.
This is alpha. This is where you're standing when you measure alpha.
Fish, you mean?
This is beta.
That's what I said.
Yeah, that looks like a beta. Don't. It's a B.
Okay, that's alpha.
I call that one
It's a
beta.
fish.
Fish, alpha.
It's fish.
No, it's alpha. Why do we have a beta?
Because what happens is you can't measure 2 angles from here because the top is just the top. So what you do is you measure this angle. I don't know the height, so the best thing I can do is back off a little bit and measure another angle.
So you just want to like. I'm so confused.
Well, I'm trying to find the height of the mountain, this H here, how tall this thing is. So to find that, I have to have a couple measurements. Like the flagpole, I needed 2 measurements, but in that case it was just 2 angles. In this case, it's 2 angles, but they're separated rather than together. You'll see why in a second. So I have X down here. Let's say I backed off 100 meters. So we're going to measure this in meters.
A mountain big.
Now you will give us this stuff on test, right?
I just have a question.
Go for it.
Yeah, me too.
What?
Well, we're not talking.
Oh,
I'm not
wait, what's the
ready.
question?
No, we're asking
You
questions
said very
about the problem.
chatty today. We're not
Oh.
talking. Oh, okay.
Question.
Why are you, what?
So, with like, when you find it, would the bottom be like 100 plus X? Or like,
We're getting there.
okay.
We're getting there. So this separates into 2 triangles. Big green triangle. Guys.
Mountain looks like it's giving me the finger.
So this angle here is the green triangle. This is beta. The distance between here and here is the same as the distance between here and
There.
here. How far is that?
100 plus X.
100 plus X, or X plus 100, either or. And the side we're interested in is over here, which is the height of the mountain.
Alright.
Blue triangle will be the smaller one.
Hey, slow down.
Oh.
Yeah, you're going really fast.
Do not pass go.
I hear people chatting, so I go faster.
No,
Oh.
I'm not. No.
Especially with the medium.
Alpha. Right angle. What's the length of the base of the small triangle?
100. It's like
X.
X.
Hold on.
That's the distance
Yeah, that
from
one.
here to here.
Wait.
We're
Okay.
still looking for the height.
I'm sorry. Hold on.
Blue triangle, alpha angle, starts here, goes to here. That distance was already determined to be X. So that side is X, this side is H. Now, the function that associates both of these triangles is tangent. If we use a tangent, this problem becomes twice as hard. So we're going to go backwards. Cotangent.
Why is it? Yeah, why is it?
Do you want to see really?
No.
No.
No,
So let's just keep it.
actually.
Trust me on this problem, you want to use cotangent.
today. That's the new one.
Yes.
We could do tangent, it's not a big deal, but cotangent works better. So we're going to set these both up with cotangent.
Well, how are we gonna know that on the test?
If it's a mountain problem, you do cotangent. If you're trying to find the height of a hill, you do cotangent.
Alright. Fine with me.
If it's that situation,
Or
cotangent.
dig a hole.
or dig a hole through the center. So if I set up the green one sets up as cotangent of what?
The tangent sets up, wait, what?
It's going to be your beta.
I can't, what? I can't hear you.
Cell
You hate cell phones? I love cell phones.
phones. Cotangent of beta is equal to
Why would
x
you-
plus 100 over h.
Why is that one in blue? Can't you put it in green?
I'm sorry. I was just going to do everything else in blue now.
No.
Oh, don't worry about it.
I
What's the
ain't
other
worried about
one?
it.
Cotangent of alpha is equal to x over h. So we have two equations based on, now assume the angles are already known. So the two variables I have are x and h. Which one am I more interested in?
X plus 100.
Mine the first one.
H, you're more
H. I'm looking for the height of this mountain. So when I look at this as a system of equations, the variable I could care less about is
That one.
x. So basically what I want to do is I want to solve both of these equations for
X.
x, the variable I could care less about. So if I solve the top one for x, what do I get?
I don't know.
X equals,
That would be.
Cotangent of beta.
Hold on.
Or H cotangent.
multiply both sides by h, you get h cotangent of b
Minus 100.
minus
100.
100. Okay. And if you solve this one for x,
Hold on. I gotta write
H
this.
cotangent.
h cotangent of alpha. Alright, so we have these two equations, and they're both equal to that base distance that we don't know anything about and actually do not even care about.
So you set them equal to each other.
So you set them equal to each other. So you get h cotangent of beta minus 100 is equal to h cotangent of alpha.
I'm just on a roll today.
Alright. What are we trying to solve for?
Trying to solve for H.
So how do you solve for h when they're on two different sides?
Put
You
them
do
on the same side.
Put them on the same side. So what I'm going to do is I'm going to switch the 100 and the h cotangent of alpha
And you change the sign.
to make the 100 positive. You know, add 100 to this side, subtract h cotangent alpha to this side.
Gotcha.
I'm just switching places, that's all.
Okay.
I'm saying,
Anyway.
when it's H cotangent, isn't it H cotangent alpha? Isn't that like all multiplying?
Well, it's h times cotangent of beta, h times cotangent of alpha.
Oh,
So
so
then
you
you
can
divide by
subtract.
H.
You got so you can subtract. You don't have to. I think it would have to.
Yeah, I'm
divide.
taking the whole piece. If I take the whole piece, I can add and subtract whatever I
Oh,
want.
you're just taking move the H.
Oh, no, no.
Okay.
You couldn't cancel the H cotangent out, can you?
No,
No.
cotangent is a name. You can't mess around with names.
Oh, so
You
you
can only
move the
mess
whole
around with
thing.
numbers.
You move the whole H cotangent alpha and move the
Yeah, I'm moving whole chunks. You can't move little tiny pieces of it. So you get h cotangent beta minus h cotangent of alpha is equal to 100.
Well,
Now, how do I solve from h
just
for
give me a
this?
second. Give me a second.
Oh, give her a second. Give her a second.
Okay.
Give her a second. Factor out an h.
Yep.
So you kick out an h, what's left behind?
Then you just divide those, right?
Cotangent of beta minus cotangent of alpha. And this equals 100. And then you get h is equal to
100 divided by
all that mess. Cotangent beta minus cotangent alpha.
It still tells me nothing.
Tells you a lot. This will measure you any distance in the way far away from you as long as you back off and can measure two different angles. If you back off and you measure the same angle, it doesn't work
This
really
is
well.
what those people with the
Sticks do. But they use a computer to do all the calculations. And they use law of cosines, which is a little easier because you don't have to worry about having a right angle.
Why don't we use cosine?
Law of cosines, we will, chapter 6. It's coming.
No, we're still going live with them.
We're in chapter 4. We have to go through 5 to get to 6.
Are we doing like Trig for the rest of the time?
For the most part, there's a little bit of other things like vectors and whatnot in there, but mostly trig. So you're gonna get sick of these 3 letters. So, for
Yeah.
instance,
Is our tax money going to pay for their jobs?
yes. So if
What
alpha,
in the world?
let's say we back up our 100 meters and we measure alpha to be 18 degrees. I'm putting some numbers in here.
Oh.
So I don't get as much money. But
So- the first angle I measure up is 18 degrees.
Uh-huh.
The second measure has to be,
Are they gonna give us this?
I'll be giving you alpha, beta, and how far away. You have to be given alpha, beta, and how far away to find H.
You definitely told me when we started this thing. How do you find it without any angles?
I did not say that.
Yes, you did.
That's to be bigger.
You interpret this.
I do not interpret this.
So, does beta have to be bigger or smaller than 18 degrees?
Bigger.
Smaller.
Wow.
Because you're pulling further away, but the height is staying exactly the same.
Oh, it makes sense.
So it will be a little bit smaller. So let's say beta is equal to 16 degrees. So moving 100 meters back, we lose 2 degrees. Now, you could derive this formula with those numbers in it, but it's really not worth it because all you have to do is plug in
Plug it
code.
into a calculator.
Yeah, but too bad I'm not going to give you the formula on the test. If you can memorize it,
I
great.
can memorize that formula right there.
Good luck with that.
Right there?
Yep.
I
So
remember that.
H
That's easy. That's
is
easy
equal
for me
to
memorize.
100 over cotangent of beta, which is 16 degrees, minus cotangent of alpha, which is 18 degrees. The problem is not getting it into the formula. The problem is getting it into your calculator. So when you type this in your calculator, it's got to be 100 divided by, parentheses should be the next symbol you do after the division.
Yes.
Now, how do I get cotangent of 16 degrees in a calculator?
Inverse tangent.
What?
Just kidding.
Huh?
Oh my lord. You write tangent of 16 degrees. Do not hit inverse.
No, I'm not saying that. I'm talking to myself.
You hit the button that says x to the negative 1.
I got it.
That reciprocates it. It flips it over. It makes it 1 over tangent. Because that's what cotangent is 1 over tangent.
But what can we put the inverse of, like?
Inverse takes ratios.
Can
It
you
does
put
not
the-
take degrees.
Can you put the inverse inside the parentheses?
If you do, you're taking the reciprocal of the angle. You want to take the reciprocal of the answer, the ratio. Minus tangent of 18 degrees, but that ratio has to get flipped, so it becomes x negative 1. And then you hit equals.
You don't have to put that one in parentheses.
You can if you want.
Oh, I don't want to over.
The calculator understands if you stop it that it's going to close all its parentheses.
Mr. Warren,
I got it.
can I go outside and call my grandmother?
Alright, I got 244.
Tangent 16 inverse. I said it.
I got it.
What'd you
Tangent
get?
of 18.
244 meters. Oh, 0.1.
244.1 meters. So this turns into 244 meters.
Oh.
I got a feeling you're
0.1.
I got a feeling you're gonna
Right?
ask us
No, that's
find that one and then do the formula and then give us a number 11. Would you do that?
Derive the formula for the height of a mountain. Yes.
I cannot believe
Why
that
not?
I don't make
I didn't
as
ask
much as
that.
I should be making.
Money?
Money comes out of my paycheck to pay for people carrying a stick.
Yeah, but that stick is very important so that when you're driving in
Oh,
a rainstorm,
It's all how you
the
use it.
water drains off the road instead of puddling up and causing you to hydrofoil.
Well, that's why.
Hydroplane,
I
I'm
was
sorry.
watching this, no, I watched that show, that
I'm
thing,
gonna pick at that.
and they were doing that thing about the ghost kids, like pushing the cars over the train tracks. But really, because they thought because the way it looked, it looked like it was going downhill, but when they did all the measurements, it was going uphill.
What are you talking about?
I have no idea.
It's just that, it works. This stuff is important, like, if you think, because even though you think it's going up, it could be going down.
Hey, guess what?
Are we doing protein now?
No. Mass spring system.
It's quiz time.
Is it really?
Oh darn.
You said there were 4 problems.
Oh my
and they
god,
were
and there's
hard.
4 simple ones.
Oh my god.
Mass
how
spring
you
system.
see it?
Now, under a mass spring system, have you ever learned Hooke's law?
No.
We go to public school.
Springs have a spring constant, and
No.
the distance that you can pull the spring away is proportional to the force it takes to pull it that far
You're
away.
talking
We're in
gibberish
high
to me.
school.
We're not. We're
Oh,
public school.
oh well. With Hooke's law and
Line up.
have you ever heard of force equals mass times acceleration?
Yes. Yes.
Yeah.
Alright. So there's two little things that go with this. Force equals mass times acceleration, and force equals, in this case, ky. Have you ever dealt with directly proportional, inverse proportional, jointly?
Just a former.
Oh dear
Say
lord.
something about a joint.
So K is called a spring constant. Wow. Now, according to these two formulas, if you put them together, obviously they're both equal to
This took time.
a force. There's ways of doing this. You get an equation that looks something like this.
Opposite of spring.
Get an equation that looks like this. And what happens is you pull the mass down a little bit and you let it go. And after you let it go, what's going to happen? It's going to go up and down, up and down, up and down.
Like a
Because it's on a spring. It's just going to bounce back and forth. So it has
It's like a slinky.
It looks like a slinky. I guess you could
I
think
said
that.
it's like a slinky.
Except slinkies compress all the way and these springs don't compress all the way.
Oh.
So if you compress them a bit, they're going to push back.
It's like
Where slinkies, if you compress them, they're not pushing back.
it's like a bed. What's underneath the
Like a
bed?
bread
bed
spring,
spring.
yeah, and a shock absorber on a car and all that
Okay.
kind of stuff. So if your shock absorber on the car, the cylinder part is bad, all you're going to do is...
Hydraulic.
So this becomes the equation of a mass spring system where you let it go and it starts following this curve, kind of like a Ferris wheel, same idea. The distance off the ground of a Ferris wheel follows a cosine sine curve.
I forgot. All right.
So if this,
Yeah.
well by the way, this
I already forgot
is
what you're talking about.
omega. It's not W, omega. It's a Greek letter, omega. It's called circular
Dystrophy.
frequency. Circular frequency. So if I give you a formula that says, well, I have this system that follows this. Follows this model. So I pull the mass down and I let it go. The 12 tells me how far it's going to go. From equilibrium, it's going to go 12 high and 12 low. The 20 pi is going to tell me what about this function?
I mean, it
Eventually.
runs around. It goes. Which will
The period. We're eventually going to get to the period of this.
Yeah.
So you take the period, which is built in here, and you say, well, this is 20 pi t, and we're going to set it equal to
Pi.
2 pi,
Uh,
and divide both sides by 20 pi, and you get t equals
110.
110. So what does this tell you?
It equals
This is like the bank equation. The higher the number was, it still only gets a little bit of.
T
No, not that
equals
bad.
Oh.
T equals 0.1. That's just what it's telling me.
Well, it's 0.1, I know that, but what does it represent? This is usually
1/10?
seconds. In 1/10 of a second, what happens?
That's one revolution.
One
One
revolution,
spring,
but
one
in this
bounce.
case,
One bounce.
one bounce. It goes down, comes up, and comes back to where it started.
Okay.
So this is how long it takes to do one cycle. Now, what happens if I flip it over and I say it's 10? This is 1/10 of a second per cycle. If I flip it upside down and I get 10, that becomes...
10 seconds per cycle.
No. I flipped it. So that also takes these two and
10 cycles
10
per second.
10 seconds.
this is cycles
Per second.
per second, also known as HR. It's HTZ. Hertz.
H&R block.
Hertz.
HRZ.
HRZ.
Those are hours, isn't it?
I thought it was.
Hours is
hours.
an F.
I thought it was a
HTZ.
T. HRTC.
Something like that.
HRTZ.
Can we just put
I don't
H?
know. But it's cycles per second. I forget the abbreviation, but it's
Who cares?
Hertz.
It's Hertz.
Cycles per second.
Why don't we
This-
just spell it out now?
hold on.
We've
This
written
is
4
called-
to 5 letters.
Frequency. The frequency of a radio channel. When you turn your dial to 1440, that's its frequency.
Mhm.
It does 1440 cycles per second up and down of a radio signal. That's how you can change your channels because you're changing what it's looking for cycle-wise. AM.
Who listens to
AM is boring.
Who
AM is
listens to AM?
AM measures in hertz. FM measures in megahertz. So hertz.
I didn't even know that. So
What is
Me is AM.
AM is just
Because
hertz.
anytime,
It's measured in hertz. It starts
anytime I
at
turn to hertz,
800 to about 15.
What are they?
anytime I go to AM,
Oh,
though, all I
nothing
hear is
anymore. It
static.
used to
Yeah.
be radio. It used to be
So
radio.
that's what old people use.
Basically, news broadcasts go over that and a few other weird
My
things.
daddy listens to the basketball games when we're driving.
But there is a good thing about AM. Since it is a lower frequency, the distance it travels is greater. Higher frequencies, the distance they travel is shorter. So FM stations, you'll find them going staticky really quickly. If you change to AM, you can hold that station for a lot longer on a long drive.
But all I hear is
Yeah, basically, because it's hardly
whenever
even
I
there
hear
anymore.
it.
All right, so the only thing left is
Quiz time.
how to find this omega.
Oh, well, we'll save that for tomorrow.
We'll save that for tomorrow. Tomorrow? You want to come
Monday.
tomorrow?
Monday.
Oh,
She wants to get pinched tomorrow.